Hi, I'm Geoff Perlman, founder and CEO of Xojo, and today I'm going to show you what we've been working on and give you a little sneak peek at what's coming up in Xojo in the not too distant future. Let's jump right in. All right, I want to start by highlighting a few things we've released over the last 12 months. In the last 12 months, we've added 48 new features, we've made 75 changes, and we've fixed 465 bugs. Now, of the improvements we've made, I want to cover just a few of the highlights. We've added URL connection on Windows. We've added graphics path for drawing Bezier curves. We updated folder item on macOS to use the most modern APIs. And we made the Xojo project format much faster. So if you're using Git or SVN, you've probably noticed that that saves much faster now. We made the navigator faster. We added list box iterators, which makes your code cleaner, easier, and a little faster if you're iterating through all the rows of a list box. We also added dark mode for iOS. In this example, I'm using the conference app, and you'll see that app in other parts of my presentation. We added color groups. Now, a color group, as the name implies, allows you to create an object that you can use in your projects. You can then later choose to change the color without having to update your code. Now here's an example. I'm going to go to the Insert menu. If you haven't used these, check this out. You can add a color group, and of course you can name the project item whatever you want. You can pick a color. You can have a single color, a blue, or a dual if you want light mode and dark mode colors. Or you can use the named colors, and this is again for light mode and dark mode, and these are system provided colors. So you can pick from those and use one of the ones built in, like here's Link, for example, to have the appropriate colors for Link for light mode and dark mode. So those are color groups. We delivered API 2 for the desktop in 2019 R2, and I'll have an update about this for other platforms later on in this video. Now, we've also spent a lot of time over the past year on some big new features, so I want to take a look at what's in the works. Let's start with Xojo Cloud. So when we ship the new Web Framework 2.0, we're going to be making some changes to Xojo Cloud to support Web Framework 2. First is all the apps will be 64-bit because modern Linux distros are all 64-bit. We're adding named hosts, which will allow you to point a domain at a specific app rather than at the server itself. For apps built with Web Framework 2.0, we'll be switching away from CGIs to standalone apps, which will allow us to utilize modern web protocols. And last but not least, we're adding load balancing. We're going to put a load balancer in front of each app so you can easily handle more concurrent users. Now, these are, again, changes that are going to be applicable to apps built with Web Framework 2.0 only. Your Web Framework 1.0 apps will continue to work as they did before on Xojo Cloud. I just want to remind you, you can try Xojo Cloud yourself anytime. Just go to xojo.com to order a server, and in a couple of minutes, you'll be ready to deploy your first app. We handle all the security, updates, and maintenance, so it's hassle-free, and there's no commitment at all. You can cancel anytime you want. Next, let's talk about feedback. We're working towards moving to a web-based version of feedback, which is being created with our 2.0 version of the web framework. This will allow us to more easily and quickly update feedback when necessary. And we've also heard from some users that they've had trouble connecting with the desktop version, so a web version is going to solve that problem as well. Now, this is still in development, of course, so it's likely to change before we ship. But it basically works the same way the desktop app does. You have a search field at the top. You type in a value, you get a list of search results, as you can see in this screenshot. And when you click on a particular row in the list box, you then see the details of that. Again, the UI will change as we get closer to rolling this out, but this gives you a pretty good idea of what it's going to be like. It pretty much looks like the desktop version. And our plan is to start public testing of this web-based version of feedback with the R1 testing cycle. So you'll be testing a new version of feedback along with R1 itself, for those of you that are pre-release testers. Next, I want to talk about the web framework, or specifically Web Framework 2.0. In Web Framework 2.0, we have a lot of great looking new controls. It handles automatic session restoring, which means if the user presses the back button or presses refresh, you don't lose your session as you do today in Web 1.0. It also has automatic reconnection, so if the user's internet connection drops for a moment, the app will continuously try to reconnect for a time, and hopefully if their internet connection only went down very briefly, they won't lose their connection. And it means your session doesn't go away either, so it just provides a much more robust user experience. You'll also find that CPU usage is about 50% less than that of Web Framework 1.0, which is really great. We've done some performance optimizations as well. Let me give you just one example. So adding 10,000 rows to a list box with Web Framework 1.0, that takes 66 seconds. In 2.0, it takes only 11 seconds. That's 6 times faster. So that's just an example, one example of the improvements we've made in terms of performance. There are many others as well. Now that's a quick preview of some of the highlights in Web Framework 2.0. I didn't talk about any of the details. To get all the details, you're going to want to check out the Xojo Web Framework 2.0 video in the XDC 2020 playlist here on YouTube for all the other details. It's a really great presentation. I think you're really going to love it. Next, let's talk about iOS. We've got some new iOS features coming. The first is local notifications. We've added a table search field, so you can now have search built into your tables. Here's the XDC conference app, for example, and you can see the search field there. That field is not above the table, it's embedded into the table, so it'll scroll off the screen as the user scrolls. We've added application shortcut items. Now these are menus that can pop up when the user taps and holds on the application icon. This is from the XDC conference app, for example. You have sessions, locations, news, etc. If you've downloaded the XDC conference app, you're probably wondering, hey, wait a minute, why haven't I seen these two features? Well, hold that thought for a minute. The next feature we've added for iOS is custom URL schemas. This lets your app define a custom URL which, when tapped by the user in some other app, will launch your app. Now those of you with iPhones can actually try this. This QR code has a custom URL schema built into it that the XDC app uses. If you have an iPhone, pause the video, go to your camera app, and point it at this QR code. A button's going to appear asking you if you want to open the XDC app. Go ahead and tap that. Bam, you've just enabled these new features in the XDC app. So now you've got a search field in the table if you scroll to the top, and an application shortcut menu on the home screen. And of course you can see that custom URL schemas are working as well. Now if this didn't work the first time, force quit the conference app and give it another go. We've had some users in testing not be able to do it the first time, and it's worked the second time when they've relaunched the app. We're also adding support for plugins for iOS projects. This means that plugin authors who now write plugins for the desktop and the web will be able to write plugins or port their existing plugins for use in iOS. Now we're in the process of bringing API 2.0 to iOS. What does that mean exactly? Well, it means that string will replace text. So you'll be using string now in iOS just like you use everywhere else. Variant replaces auto. There will be new mobile classes that replace the iOS classes. For example, iOS button will be replaced by mobile button. And the new mobile classes are all API 2.0 compliant. These new mobile classes are also nearly identical to their Android equivalents. And just to be clear, these are still native controls for iOS. We're not drawing the controls ourselves or anything like that. They're still native. We're just using a common base class so that your code can be compatible across different project types. Now, because we're switching to string and variant for iOS, this is going to allow us to bring over some features from the console framework that iOS previously has been lacking, such as regex, XML, URL connection, UDP socket, and others. Now we're not going to be able to bring these all over in one go, but you'll start to see these come over in future releases once API 2.0 lands for iOS. Now bringing API 2 to iOS is our next step towards our goal of consistency across all project types. So far we've delivered API 2.0 for desktop. Web Framework 2.0 is API 2.0 compatible. The next big update to iOS will make it API 2 compatible. And lastly, Android is, of course, API 2 compatible as well. Now to drive this point home, let's look at an example. Okay, here's a desktop project with a couple of fields and a button and a text area, and it's got some code that takes the values of the two fields, puts them together with the date and time, sticks it in the text area. So let's run so you can see what this looks like. I'm going to type in my name, press the button, bang, it's in the text area. Great. So now let's make a web app. This is going to be using Web Framework 2.0. And I'm going to just duplicate the same UI. I'm going to add a text field, another text field, add a button and a text area. And then I'll go to the pressed event and paste in the code. Identical, didn't have to type it over again or change anything, identical code. Let's run the app, type in my name, press the button, bam, same thing. Identical code, not one change. Now let's try that again, but this time with an iOS app. I'll build the UI, a couple of text fields, and a button and a text area. And again, I'm just going to go to the pressed event and I'm going to paste in that same code, unchanged. Let's run. And I'll type in my name, press the button, bingo. All right, last but not least, let's try an Android app. Let's put in a couple of text fields and a button and a text area. And once again, we're just going to paste in the exact same code that we used in all the other apps. There it is. Press run. Press the button. Bingo. With API 2, we're going to have a consistent API across all project types. And as you saw in the demo, you'll be able to copy code that in most cases will be untouched, exactly the same from project to project. Now obviously, we still have APIs that are unique to particular OSs, like there's stuff that's just there for iOS or just for Android or just for web, just for desktop. But all the code that is not specific to a particular kind of device or OS will be compatible across all of your projects. But there's one exception right now, and that's desktop events. As you know, we changed the desktop to the new events, but it created some backward compatibility issues for some users. So we reverted them, but that's always been a temporary fix. So sometime around or after Android ships, we'll be adding a new set of control classes for the desktop. They will be nearly identical to the existing controls, with the exception that they'll use the new API 2.0 events. Now, because these are new classes, you can choose when to adopt them, eliminating the backward compatibility issues. Now, we've made tremendous progress over the last 12 months on Android support, and in fact, it's going so quickly now, I'm seeing new features added nearly every single day. A good example of our progress is the native Android version of our conference app, which is available in the Google Play Store. If you haven't already downloaded that on your Android device, go ahead and just search for Xojo and you'll find it. You'll see we've got tables now, we've got graphics, we've got some URL support to launch maps, things like that. There's quite a bit there. We still have more to go, but it's a really great example of how far we've gotten. Now, if you want to check out all the details in the nitty-gritty of our Android support, you'll want to check out our Android video in the XDC 2020 playlist to get those details. In that video, they'll go into all the nitty-gritties. You'll definitely want to check it out. Next, we've been doing some work on graphics lately, and I have a couple of cool demos to show you. Okay, so this is a built app. It's got a canvas area up here at the top. There's a text area at the bottom. And I'm just going to paste in some graphics code into this text area. And remember, this is a built app, right? All right, so I'll paste this code in. and it's drawing in the graphics area at the top. Now, that may not seem like a big deal, but if you think about it, how are we doing that? This is at runtime, not design time. Well, the way we're doing that is we've added code to allow Xojo script to do graphics. Now, the original purpose of this is to allow people building custom controls to use Xojo script to draw those controls in the layout editor at design time, which is great because it means that they'll work just like our built-in controls. But this also allows you to use graphics in Xojo script in your application. So for example, if you have the kind of application where you need the user to be able to actually write some graphics code, you could do that. You could have them type in some code and have that execute at runtime in your application to draw graphics. So we'll be interested to see what you guys do with this. Okay, for my next demo, I'm using a standard desktop project. I've got a window with a canvas control and a print button. The canvas control has a paint event, and it's simply calling a method of the window called drawBarChart, which is being passed its graphics object. And drawBarChart is a method I added that doesn't do anything particularly interesting. It just draws a random bar chart. And as you know, if you've done graphics before, you can do the same thing with the printer. In my print button, I have the print dialog coming up with the show printer dialog. It returns a graphics object. I can then pass that graphics object to my drawBarChart method and basically use the same exact graphics code whether I'm drawing to the canvas or to the printer. Now again, that's nothing really new, but I want to show you something we're working on right now for a future release of Xojo. I'm going to add a button, and let's add the action event, and I'm just going to paste in some code here and then I'll explain it. So I create a folder item, and I'm using special folder.desktop to create a folder item on the desktop called barchart.pdf. And then I'm creating a PDF variable with our new PDF document class. This is something we're adding to Xojo. And I just pass the graphics object, rather the graphics property of PDF to the drawBarChart method I wrote. Then I call pdf.save and pass it the folder item. And then just so it opens in front of you, I'm calling f.open to open the folder item. So let's give it a whirl. All right, there's my bar chart. I'm going to click the button, and it opened the document. There's the bar chart, and you can see over here on the desktop, there's the bar chart PDF file. So now you can use the same code that you've used before for doing any kind of graphics, for printing, for drawing to the canvas. You'll now be able to use it quickly and easily with just a couple of lines of code to write those same graphics to PDF files. Pretty cool. Now let's talk about threads. You know, over the years, users have asked us if we could make it so that threads could run on individual cores to enable parallel processing in their apps. That's actually a really hard problem. You know, threads, it sounds great, but threads have problems. Let me give you some examples of threads, of the kind of problems you can have with threads when you're trying to run them on multiple cores. First of all, accessing anything global is problematic. You could end up with threads running on different cores, accessing global information. One thread doesn't know that another thread has changed it. That can be a real problem. Frameworks are usually not thread safe, and ours is no exception. GUI libraries in OSs, meaning the code in the operating system that handles buttons and windows and menus and all that stuff, they're never thread safe. So that's a big problem. But we know that you guys don't care about any of that. You just want it to work. And we do too. And there actually is a solution to this problem today. For those of you that don't know what this is, let me explain it. So you got your app, and in addition to your app, you can create a console app that does a specific job, processing a large amount of data, for example. Maybe you've got a bunch of photos and you want to create thumbnails of them, for example. Well, you create a console app. In this example, we'll call it Worker. And what you do is you have your desktop app or your web app, whatever, launch this console app, and then you use an IPC socket to pass data back and forth between the Worker and your app. Now, since the Worker is a separate application, it can run on its own core. And if you have to process a lot of data all at the same time, then you just launch multiple instances of your Worker app. Once all the worker apps are done, they've handed their data back to your application. Your application can deal with it. Now, yes, this is a lot of work to set up, and it can be a bit of a mess to debug, but it does work, and it's something that you can do today. Let me show you an example so you can see that it's not as hard as you might think to convert a project to using console apps to get multi-core support. So here we have a desktop project. This is a image thumbnail generator. So basically you can take a folder full of photos, drop it on the list box in the middle. It then loops through all of the files and creates thumbnail versions of them. So it takes photos that are maybe 2 or 3 megabytes and turns them into thumbnails that are significantly smaller. So I'm going to run the app first so you can see how it works and how long it takes, and then we'll take a look at the code. So I'm going to press run. There it is, and I'm going to drag my folder, drop it in here. It's 287 photos. There they are, lots of photos. Okay, so I'm going to press go. It's going to run through and process all of them one by one, converting files, like I said, from maybe 2 or 3 megs down to, I don't know, something like 20 or 30K. They're very, very small. And it's done. Great. That took 13.7 seconds to complete. Now let's take a look at the code. All right, so we've got our go button. Double click on that. That's where a lot of the work is being done. So we're just getting the start time so we can keep track of how long it takes. Then we're looping through the code, or rather looping through the list box. And we take the row tag, because that's where I'm storing the path to the file. And we pass that file path to a method of the window called process image. That does the actual thumbnail processing. Then we remove that row from the list box. Then we update the progress bar. Then we're calling app.doEvents because we're doing this in a tight loop and we want our progress bar to update, so we're giving the app some time to do that. And once we're done all the way through the loop, we call message box to see how long it took, and it took 13.76 seconds. Okay, let's go over and look at process image. That's doing the actual image processing, hence the name. So we're basically just simply getting the original file and then making a new one, and we're opening the original file. We're then creating a new picture. We're scaling the picture down and saving it into the new file. It's really, really straightforward. All right, so I'm going to first show you the converted app so we can see how much faster it is, and then we'll take a look at the code. Okay, so here's the same app. It's been converted to use a console app to get multi-core support. So let's do the same thing. I'm going to drag the folder in with the photos. There they are, same number of photos, 287 photos. And let's press go and see how long this takes with a multi-core version of the app. Obviously, it's quite a bit faster. 3.15 seconds. Great. Okay, so here's the project that's been converted, and let's take a look at the code so you can see what it's like. So let's start with the go button, since that's where all the processing was happening. And we start the timer as before, but wait a minute, the code seems to be missing. What's going on here? Well, it's calling this main worker item and calling start. What's that? Well, I kind of deceived you a little bit. We're actually not going to build a console app at all. In fact, what we're going to do is use a new type of class that we've been working on for Xojo called a worker. And I've added one to my project here. I called it main worker. And if I open it up, you'll see it's got 3 events. First of all, there's an event for requesting a job. And this is where you dole out the jobs that you want your workers to do. So in this case, I'm simply checking to see if, once it requests a job, see if there's any rows left to process. If there are, I get the path to the file out of the row tag, just like before, store that in file path. Then I remove that row from the list box, and then I return the file path so that picture can be processed. Well, that file path is then passed to job run. So this is where we do the actual processing. Now, you can see that the job run has a parameter, job data, but this is identical to the other method in the single core version of this. It's not changed one bit, exactly the same code. And then when a worker finishes a job, it calls job completed. And all we're really doing in job completed is simply increasing the progress bar value and then checking to see if we're at the end of the progress bar, if we finished all the jobs. And if we have, then we know to bring up the message box so we can see how long it took to finish the job. Now, when you add a worker class to your project, you can set in the properties what percentage of cores you want it to use. I'm on a 16-inch MacBook Pro, so I have 16 cores, and how many cores maximum you want it to use. But that's basically it. We generate the console apps for you. We create the IPC sockets. We take care of managing all the communications back and forth between the console apps and the your main application. You don't have to worry about any of that stuff. That's all happening behind the scenes. All you do is put your code in, that was in a loop into the job run event of a worker class, and then if you need to implement you'll need to implement job requested so you can pass it the data, and then job completed, which you may or may not need. In this case, like I said, it's just so we know when the whole thing's finished. So what we've done here is we've created a new class for Xojo that makes it so that almost anybody who's familiar with Xojo can take code that was running in a long loop, taking a lot of time to process, stick it in a few events of a new class, and dramatically decrease the amount of time it takes by utilizing multiple cores. In fact, in our example, the original version took 13.7 seconds to complete, and the multi-core version took just over 3 seconds. It was basically about 4 times faster simply by moving a little bit of code around to use our new worker class. So now you'll be able to implement multi-core applications, and I think what you're going to find is that it's so easy to do now that you'll be able to use it in lots of data processing applications throughout all of your projects. So we're really excited about this. We can't wait for you to get your hands on it. So we can finally see the light at the end of the tunnel for our big multi-year projects and have some new features coming as well. We're adding features to Xojo Cloud. We have Web Framework 2.0, and again, you'll want to check out the video on that to get all the details. We have a web-based version of feedback coming. We've got API 2 for iOS, and new features coming as well. We've got API 2 coming for all project types, as you've seen in my presentation, and you'll see more in the videos that accompany this in the XDC 2020 playlist. And we've got a big update with Android. And last but not least, we've got multi-core support coming as well. So those are the big new things coming right now. Several of these are things we've been working on for several years, and we're really happy to start to finally see the light at the end of the tunnel, which is really great. One last thing. This year we had to cancel our XDC conference in Nashville because of the coronavirus pandemic. It was unfortunate, but it was the right thing to do. We certainly don't want to be part of the problem. We want to be part of the solution. But we have been planning our next conference. We start that before this year's conference. So I'm happy to say that next year's conference is going to be in London, England, if you haven't heard already. It's April 21st through the 23rd. Not this year, of course, but 2021. And if you want to get all the details, go to xojo.com/XDC. We've got early bird pricing, which can save you a lot of money. That early bird pricing is available until April 15th. So that's my update for this time. And thanks for watching, and I hope to see you in London.